Air pollution occurs when gases, dust, particles, and fumes or odors are introduced to the atmosphere in a way that makes it harmful to human, animal, and plant. Air pollution threatens the health of human and other living beings on our planet. It creates smoke and acid rain, causes cancer and respiratory disease, reduces the ozone layer, and contribute to global warming. Although air pollution in the modern industrial era cannot be totally avoided, action can be taken to lessen it. In an effort to reduce air pollution, the government has created and still creating regulation for air quality and law that limit the emission. Type and classification of air pollutant. Air pollutant is a substance in the air that can adverse to human and the environment. Basically, there are two types of air pollutant, which is primary pollutant and secondary pollutant. Primary pollutant result directly from a process such as sulfur dioxide discharge from factories, carbon monoxide gas from automobile exhaust, and ash from volcanic eruption, while secondary pollutant form in the air due to interaction or reaction between primary pollutant. The status of being most polluted city in the nation and in region is frequently given to Hanoi. In and around Hanoi, it is estimated that 500 tons of charcoal and 700 tons Vietnamese waste are burned each day. Burning this substance produces harmful gases including carbon dioxide, carbon monoxide, and sulfur dioxide. According to an analysis in Hanoi, the average annual mean value in 2080 for CO2, SO2, and NO2 is 148 microgram per meter square, 66 microgram per meter square, and 16 microgram per meter square respectively. This is a relatively large number that warrant concern and immediate treatment. An effective method of reducing air pollution should be proposed in this proposal to help control this air pollution problem.
For the objective of this project, we have three objectives. The first one is to understand the major cause of air pollution in Hanoi, Vietnam. The second one is to suggest and propose new treatment for the air pollution. And finally, to set a financial budget and report for the proposed solution. Next is the scope of this project. The project is in Hanoi, which is one of the largest cities in Asia in terms of both area and population impacted by its worsening air quality. The main causes of air pollution in Hanoi are particulate matter release from industrial plants and construction. Existing interventions and measures employed by Hanoi need to tighten enforcement, speed up or innovate to make some headway in arresting the continuous deterioration of cities' air quality.
For this project, the proposed solution from our group is to install wet scrubbers in reactors and plants such as acid plants, fertilizer plants, steel mills, asphalt plants, and large power plants. The primary purposes of wet scrubbers are the removal of harmful materials from industrial exhaust gases known as flue gas before being released into the environment. The primary goal of a wet scrubber is to reduce particulate matter in gases emitted by industries and to maintain good air quality. Plus, wet scrubbers are an effective way to lower air pollution in Hanoi because of city's extensive industrial base. Industrial air scrubbers can be either dry or wet, and we chose wet scrubbers. This is because wet scrubbers are more efficient than dry scrubbers. Therefore, we from Group 7 chose wet scrubbers as a result to lessen air pollution in Hanoi, Vietnam. For the work principle of a wet scrubber work by absorbing pollutant with water or a water-based solvent. The amount of energy required to bring the gas stream into contact with the scrubber liquid directly affects how effectively a wet scrubber collects particulates. A particle collection efficiency of over 95% is achieved by most wet scrubbing systems. Any industries that produce air pollutants might want to use wet air scrubbers of various design and construction. Example of wet scrubbers designs are spray towel scrubber, venturi wet scrubber, and a tray towel scrubber. In the wet scrubber, the solvent's composition affects its ability to absorb contaminants. The critical factor is the solvent's electric charge. A positive, negative, or neutral charge will allow the solvent to bind with different inorganic pollutants. So here, some of the most common wet scrubber solvents includes H2O, which is water, sodium hydroxide, calcium hydroxide, and sodium carbonate. As the solvent absorbs contaminants, the solvent is necessary to purge the pollutants and replace the evaporated liquid. Solvent flooding can be either continuous or periodic. A wet scrubber's effectiveness depends on how much gas contacts the solvent, which requires a stream of energy. Low energy scrubbers can remove large particles, while high energy scrubbers can remove the tiniest particles. All wet scrubbers, whether high or low energy, have a mist eliminator component where the mist eliminator collects and removes the contaminated droplets from the solvent. So here are the design of wet scrubbers, and here we have three designs, which are spray tower, venturi scrubber, and also tray tower. For the design of wet scrubbers, spray tower is one of the design, and is the simplest wet scrubber design, which uses minimal amount of energy to remove the pollutants in gas. How does a spray tower works? A spray tower consists of an open chamber within the vessel, which is irrigated with a spray of a scrubbing liquid. The contaminated gas passes through the chamber from the bottom, usually from the bottom, and some also have at the top. And then the gas will contact with the scrubbing liquid spray, and the contaminants are washed from the gas stream. And then the efficiency of removal for the spray tower is based on the size of the particles. For particles larger than 5 micrometer, the typical removal can reach up to 90%. While for particles between 3 to 5 micrometer, the removal efficiency is between 60 to 80%. And lastly, if the particle is smaller than 3 micrometer, the typical removal is below 50%. Next is a venturi scrubber, which is a medium and also a high energy scrubber. A venturi scrubber accelerates the waste gas stream to atomize the scrubbing liquid and to improve gas-liquid contact. In a venturi scrubber, a thread section is built into the duct that forces the gas stream to accelerate as the duct narrows and then expands. For the efficiency of venturi scrubber, it can go up to 70 to 99% for particles bigger than 1 micrometer in diameter and 50% for submicron particles. The effectiveness increased by increasing the pressure drop, but the system requirement also rises. Therefore, the operating expenses will also increases. For the last design of the wet scrubber is the tray tower. As shown in the diagram, the liquid enters the tower at the top and flows downward by gravity. On the way, it flows across each tray and through a downcomer to the tray below. The gas enters the tower near the bottom and is directed upwards through the openings of one sort or another in the tray. For the efficiency of tray tower, the efficiency is up to 97% for particles larger than 5 micrometer. However, it is not suitable for submicron particles. The liquid to gas ratio is low since the scrubbing liquid is static, and the flow rate is ranging from 1000 to 17,500 of standard cubic feet per minute. For the cost, it is slightly higher than the spray tower.
Capital expenditure, or known as CapEx, is the total amount of money spent on the acquisition of fixed asset. CapEx is the money spent to buy, improve or prolong the life of assets such as real estate, plants, buildings, technology or equipment. CapEx is usually associated with a company decision to embark on new initiative or make investment. CapEx are also a long-term investment, which means that the asset acquired will be used in few years or more, while operating expenditure, or known as OPEX, can be defined as the cost of operation, maintenance, and the running utilities operation. OPEX also can be defined as the money it spent on daily basis to run a business or system. OPEX also provides short-term benefits, which means it tends to be lower upfront costs. In Web Scrabble, CapEx can be called as the total capital investment (TCI), which can determine when the system is sized. The cost formulas are based on Sargent and Lundy methodology established for the EPA CAMD and utilized with the IPM. So this is the total capital investment formula, which 1.3 times ABS cost plus RPE cost plus WHE cost plus BOP cost plus WWT cost, where TCI is total capital investment, ABS cost is cost of the absorbed island, RPA cost is reagent formulation equipment cost, WHE cost is waste handling equipment cost, BOP cost is balance of plant cost, and lastly WWT cost is the cost of wastewater treatment facilities. Total capital investment (TCI) that have calculated based on the formula is 1,31,231,242 ringgit and 30 cents. In research from US Inventory Protection Agency, the install cost for the scrubber system reported to EIA with the removal efficiency of 90% or greater is ranged between 1 million to 3 billion, which are still in range. In Web Scrabble, OPEX can be related to direct annual cost (DAC), which include variable and semi-variable costs. Variable direct annual expenses include reagent purchases, utilities such as electrical power and water, and any additional waste disposal costs incurred because of the Web Scrabble system operation. So this is the formula of direct annual cost, which is annual maintenance cost plus annual operating cost plus annual reagent cost plus annual makeup water cost plus annual waste disposal cost plus annual auxiliary power cost plus annual wastewater treatment cost. After we calculate all the components for direct annual cost, so the total direct annual cost that we get from the research is 230,878,805 ringgit 80 cents per year.
Hanoi frequently holds the title of being the richest and the nation's most polluted city, although there are steps that can be taken to reduce air pollution in the modern industrial age. It cannot entirely be reverted. When materials are burned, hazardous gases including carbon dioxide, carbon monoxide, and sulfur dioxide are produced. Installing wet scrubber in reactor and facilities including acid factories, fertilizer plants, steel mill, and major power plant is the suggested answer for this project. Wet scrubbing is primarily used to remove hazard compounds from flue gas, which is industrial exhaust gas, before they are released into the environment. More than 99% of airborne particulate matter can be removed using the adaptable and economical pollution control technologies of wet scrubbing. Wet scrubber can process hot and sticky material, which is one of their numerous benefits. It is a great option for a wide range of industry applications due to its modest size and simplicity of usage. Your capital maintenance cost will be dropped dramatically if you use a wet scrubber. The ability to reduce air pollution is the wet scrubber's most significant benefit out of all of them. The particle size distribution and the case of Scrabble being utilized affects how well a wet Scrabble performs. For high temperature situation, a wet scrubber with a low cost model perform better than one of the high efficiency system that employ water as its liquid scrubber component. The wet scrubber not only save money but also have a potential to save life. Lastly, this is timeline project 2 for our group. That's all for us. Thank you.